All right, here we go with 4.15. We're going to be sketching and interpreting the graph of trigonometric models in context. So this is more of kind of the same, except that now when we are given a sinusoidal function, it's describing a real-life situation, and so we're going to need to take a look at that function and determine different aspects of it and interpret them in real life. So it's going to be kind of a combination of a lot of the things that we've already done. Just a reminder to continue commenting with a question or answering someone's question or both, and make sure you stay focused till the very end because I may have you add in some pieces specific to certain questions. All right, so first what I want us to do is for ourselves, outline what we would do in order to sketch the graph of a function. So just let's imagine that we have some function. It can be either sine or cosine. We'll just pretend it's sine here. All right, and so by talking about these, and with talking about these values here, I want you to go through the steps that you would do in order to sketch a graph of this function. And you can go back into your notes if you need to and look these up afterwards, but I want you to try doing this all on your own. All right, I hope that was helpful for you to kind of re-assimilate yourself with the process. And I want to just remind you that everyone has their own way of going about it and the way they feel comfortable with it. And I think I talked a little bit about how I sketch the graph of sinusoidal functions. So I'm going to put those steps back up here as a little bit of a refresher, but then we're going to move on to applying these to sketching graphs in context. All right, so here they are, and remember the first thing that we want to do is look at how they're different from the parent function. So I have a sine function here, but I want to consider the fact that maybe I have a phase shift, and so instead of the y-intercept being at the midline and increasing, maybe the phase shift has moved it to the right 3 units, and so I will, my point that was on the midline will be moved to the right 3 units. And then this would be the first step, second step, third step. Remember, this is kind of you're up for your interpretation, so you can go in different order, but this is just how I would go through it. So here we're looking at a roller coaster and thinking about the height of a car above the platform of the roller coaster. So as you might imagine, think of a roller coaster, it's going all over the place, and we want to model how high above or how far below the car is to the platform. So I provided you with the function h of t, which models the height above the platform, and want to answer just a couple of questions. So first off, you want to graph the height of the car relative to the starting platform for the first 36 seconds of the ride. And what is the period of the function? What does that mean in the context of the problem? During this time period, what is the closest the car gets to the platform? How many times does this happen? And then write a cosine function to model this same situation. So what I want you to do is go ahead and try these on your own. I want you to write your cosine function as a part of your comment. Okay, so make sure you have a question or you're answering someone else's question, and you're also including the cosine function that you wrote to model this situation. Pause the video and go ahead and try this on your own, and then press play again. I want to talk about a few things and give you one more something to put in your comment. Okay, I hope that went really well. This should be pretty straightforward for you guys. The midline is, of course, -7. So in case you accidentally put the midline up here, make sure that you're thinking about a midline of -7. Consider, of course, also the phase shift. So there's a positive phase shift. So think about what that does for your function. And then, of course, remember that the b value, what that does for your period, and that your entire b value is pi over 4. Okay, so with that in mind, you should be able to sketch this function pretty well. Give it a double check. Make sure, of course, that in your comment you're writing your cosine function that you found to model your situation. We'll talk about that tomorrow. And the last thing I want you to do is you're going to do something with your birth date, and you're going to leave that in your comment. So write out your birth date. So let's say that you were born on January 2nd. So that would be, if I wrote out the birth date like this, 1, 2, and let's say it was 1999. What you're going to do is you're going to multiply all these numbers together. Okay? So multiply all these numbers together, and you would end up getting 1 times 2 is 2, 2 times 1,999 is 3,998. Okay, and just include that in the last line of your comment. Okay, see you guys tomorrow.